Hey guys, welcome to lesson 4. We're going to be talking about inverse functions today. Okay, and what an inverse function is it switches the input and the output. So in other words, we are going to switch the x and the y. A function is said to be invertible if you can find its inverse. And it's still one-to-one. And we'll talk about that here in a second. So let's first of all talk about one-to-one functions. Okay, so a one-to-one function is when each x has exactly one y value. So a line is a good example of a one-to-one function. Because like this might be 1, 2, and 3, 4, and so you won't have the same y values ever. So it's still a function, but it's also a one-to-one function. An example of one that is not one-to-one would be a parabola. A parabola is a function, but it's not one-to-one because this might have one y value, but like if you go here, this might be like -1, 2, and this might be +1, 2. So it has the same y value, so it doesn't make it one-to-one. There are two things that you can think about that make it one-to-one. First of all, the functions are either always increasing or always decreasing. So like a good example of that is this line function is always increasing. You might have something like this where it's always decreasing. That would be another example of a one-to-one function. Also, one-to-one functions not only pass the vertical line test, but they pass a horizontal line test. So what this means is if I draw a horizontal line, it should only cross it at one point, just the same concept as a vertical line test. So I know that this function is not one-to-one because it passes it more than once. We've kind of already talked about this. So these are definitely both functions because they pass the vertical line test, but this one is one-to-one while this one isn't because it does not pass the horizontal line test. Okay, so now, just like I said at the very beginning of this video, to find the inverse of a function, we are going to flip the x and y. So remember, f of x, that's the same thing as y, representing the same concept. So if I flip these, that's going to give me the inverse. So instead of -2, 4, I'm going to have 4, -2, 0, 0, and 4, 2. Okay, so now it's asking, is the function one-to-one? So this function definitely is not one-to-one. Because think about if I graph this. So -2, 4, 0, 0, 2, 4. So this is probably an example of a parabola. This one, we have 4, -2, and 4, 2. This isn't even a function anymore. So it's not one-to-one, and it's not a function. When you have coordinate points, like we talked about the other day, to find the inverse, just always think you're flipping x and y. So to find the inverse of this function, this discrete function, I'm going to have 5, 1, 7, 3, and -10, 8. Okay, so what is the domain of this function? So remember, the domain, those are your x values. So I'm just going to list the x values, 5, 7, -10. Notice those were my previous range values. My new range is now going to be my previous domain value. So what I'm saying is that when you're finding the inverse, the domain and range flip. Okay, so here, f inverse of 5, what we're doing, so let's pretend like we didn't find this, and then we'll go back to finding it. If we're looking at the original function, we would actually start with the y value and go back and answer 1. So you can see this where we found the inverse, and we're trying to find f inverse of 5, it's just going to be our y value as normal. But if you're starting with the original function, is going to be your x value. So let's see, f inverse of 7 right here is 3. Also up here, we would go backwards and find the x value. Here, this is 8, and again, we'd go backwards if we were dealing with the original function. Okay, so if we have a function that we're trying to find the inverse of, we're still going to do the same thing. I hope you're hearing a common thing. We're going to flip x and y. So remember, this is like our y. So I'm going to say x equals 3y to the third minus 2, and our goal is to solve for y. Okay, so the first thing I'm going to do is add 2 and divide by 3. That's going to give us y to the third. And then we're going to have to take the cubed root of both sides. So a lot of times for your answer for an inverse, you've kind of already seen this already. Instead of saying y, we're going to say f inverse of x. That's the fancy way of saying it. And this would be our answer. Okay, so let's try this next one. This one's going to be tricky because it has both x's are kind of split, so our y's are going to be split. So let's see, we have x equals 2y plus 3 over 5y minus 1. So my main goal is just to get rid of that fraction. So I'm going to multiply, cross multiply. So it looks like that. And then I'm going to go ahead and distribute this x in. And we've had problems like these before, so we want to group, because we're solving for y, so we want to group the y's together and everything else on the other side. So in this case, it's going to look like this, and we're doing that so we can factor out the y. So when we do that, I have 5x minus 2 equals x plus 3, and then I'm just going to divide everything that I don't want. So my final answer, I'll write it over here, is x plus 3 over 5x minus 2. And make sure, because it's a fraction, you're going to say x cannot equal, and then make sure you're setting that equal to 0 and solving for x. So x cannot equal 2/5. Okay, graphing the inverse, you are going to flip the x and y. That's a simple answer. And it should always have a symmetry on the line y equals x. So think about this. Y equals x is that 45-degree angle through here. So no matter what your inverse looks like, if you were to fold a piece of paper on this line, your function should always match up. Your regular function and then your inverse function. So that's a way to double check yourself. So let's start with this one. So let's state all the transformations of the graph. So we should be super good at this. So we're going to go right 1 and up 2 from our original parent function. Okay, so we have been talking about this. I'm going to go ahead and make an XY chart. And I'm going to put that number in the middle. So 1, 2, and then just kind of work my way out. So let's see, I've got 0, -1, 2, 3. And so I'm just going to plug each of these values into this function here. Okay, so my function should look something like that. Now we are going to talk about f inverse of x. So I'll put this over here. And so what we're going to do is create another XY chart. And now it's just a matter of flipping the x and y. So easy peasy. So -6, -1, 1, 0, 2, 1, 3, 2, 10, 3. And then I'm going to graph this. This is a terrible graph. I apologize. But you get the idea. I want you to see something else. So notice that if I were to fold this screen in half, that those lines would match up. And so that's what you're looking for on a test. So let's go to this one. Show the f of x and v of x are inverse functions using composition. So this is what we talked about the other day. So we want to show that f of g of x equals x, and you need both of these, g of f of x equals x. And if that is true, if they're both true, if they both equal x, then they are inverses of each other. So let's start over here. So f of g of x. Okay, so I'm going to take this and I'm going to stick it into this function right here. So I have 2 times x, but I'm going to call x g of x, and then minus 6. Okay, so these 2's cancel, so I get x plus, and then I'm distributing that 2, 6 minus 6 equals x. Okay, so we're halfway there. So we've proven that f of g of x equals x. So now we have to do it the other way. So g of 2x minus 6. So I'm going to take this and I'm going to plug it in for x right there. So I have 2x minus 6 over 2. And I'm going to combine this 3 with that. So instead of saying 3 over 1, I'm going to say 6 over 2, because 6 over 2 is the same thing as 3. And so now I'm able to combine the top. So I have 2x minus 6 plus 6 over 2. So if you'll notice, these 6's now cancel out, and I get 2x over 2, which gives me x. So now I can say that they are inverses. I've proved that those 2 functions are inverses of each other. Okay, so let's try this next one. Same exact thing. Okay, so when I did f of g of x, I saw, I ended up with this. So when I distributed the 3, I got 15, and 15 minus 5, that's not going to cancel out. So I can stop here and say, no, they're not inverses of each other. So let's do one more here. Okay, so I plugged this whole function right here in for this x here. So that's what's going on down here. Notice these 2's are going to cancel out. And so I have x plus 1, the cubed root of that. And oops, sorry, I forgot this 3 here. So this cubed root and this cube, those are going to cancel out. So I have x plus 1 minus 1, and those 1's are going to cancel out, so I'm left with x. Okay, so we're halfway there. Let's see if this other one will make this true. So I'm going to say g of all of this, and I'm going to stick all of this in for right here. Okay, this looks kind of scary, so let's see what's going on here. So the first thing that's jumping out at me is that this, those 1's cancel out. So that's going to kind of clean that up a little bit. And so now these 3's are going to cancel. And so I have x plus 2 minus 2, and I'm left with x. So yes, these are inverses of each other. And we are going to talk more about inverses in day 2, but we're done for today.